Good. All right, this is section A3, and they call these, what do they call it, special triangles or something like that?
Special right triangles.
Special right triangles. Okay. So, special right triangles. I told my other class a story about that word special. Whenever I hear somebody say special, it just reminds me of my grandmother. She was from West Virginia, and she had this real southern, type accent, and she would say spatial. She says, that's spatial. Get that spatial sauce. Get that spatial. Yeah. So that's what I always think of when I think of spatial. Well, anyway, here we go. I've got a right triangle right here, and well, now it's a right triangle. Okay, and I've got this side is equal to this side. Tell me what both of these angles are going to equal if that information is given. Yeah, they're both going to be 45 because they're both equal to each other. They both add up to 90, so we take 90 divided by 2, and they're both 45. Okay, we're going to do two special triangles, right triangles today. The first one is this one right here, and we call this a 45-45-90 triangle. Okay? It is isosceles, but we're going to deal with the angles. We describe it, I should say, by its angles. All right? So we call it a 45-45-90 triangle. And you're right, it is isosceles. But I'm going to get rid of these for right now. Now you can keep them in there, but you know that they're going to both be equal to each other. There's a relationship between, let's do this. We call this the leg, and we call this one right here the leg. Now they're both exactly the same. So if I call this L for leg, what do you think I'm going to call this one? I'm going to call this L. What do we call this side right here? It's opposite the right angle. The hypotenuse, right? So I'm just going to call it H for hypotenuse. I'm not really pushing the envelope here much, am I? All right, just starts with the same letter. What I want to do is there's a special relationship between the leg and the hypotenuse. There's a special relationship, and I want to let's work this out so we figure out what that special relationship actually is. If we do Pythagorean theorem, which we just finished going over, we can find that special relationship. So let's do this. I'll just do it and I'll show you what we're looking for. You could say h squared is because what I want to do is I want to solve for h. Okay, h squared is equal to Pythagorean theorem what? L squared plus L squared. Okay, this is kind of like a little proof of what we're going to do right here. So h squared. Add those up for me. What's 1L squared plus 1L squared? It's 2L squared. Right? What do we do if we want to solve for h here? Square root it, not square it, but square root it. Okay, square root it. So that gets rid of this squared, so h is equal to, now let's simplify this. Well, let's do the 2 first. It's under a square root. Can I simplify the 2? No, so it stays the square root of 2. What's L squared underneath a square root? It's just L, that's right. So here's my relationship. This is what I was looking for. This thing right here. What does that mean? It means the hypotenuse is equal to what? The square root of 2 times the leg, okay? Times one of the legs. So, let's use that.
It is only in the 45-45-90.
Only in a 45-45-90 this works, correct. Okay, that's why it's special, because it only works... Or spatial. Why does it do that? What's going on? Alright, let's try this again. There we go. I don't know what I do to make that. I've done that a couple times. I think I accidentally like double click or something. I don't know why it does that. Anyway, here we go. Watch this. What if I had a right triangle and I told you that this was 5? Now, here's the relationship. Let's use this relationship right here. Let's not do Pythagorean theorem. Now, if I said that this was a 45-45-90 triangle, okay, these are degrees. What do we know about this bottom side right here? It's going to be 5. That's easy because it's isosceles, right? This one right here, we could always do Pythagorean theorem, couldn't we? To figure out what this is. But since we learned that relationship, look, we did Pythagorean theorem once right here to figure out this relationship. We don't have to do it every single time. We can just use the one relationship that we figured out. Alex, what do you think?
If you multiply 5 by the square root of 2, you get 1.
Exactly right. He said if you multiply 5, the leg, by the square root of 2, do you see what up here? If If I take that leg, multiply it by the square root of 2, I get what the hypotenuse is equal to. So really, without doing any math at all, really, I didn't do any computation. I just saw the relationship. I said, oh, it's a 45-45, and what did we say about a 45-45? The hypotenuse is the square root of 2 times one of the legs. So, how do we write it? Do I write square root of 2 5? That would look kind of funny, wouldn't it? So I always put the whole number first, so I put 5 square root of 2. You okay with that?
We solve it?
Do we solve it? What do you mean, do we solve it?
It's still multiply.
It's solved.
I was thinking like,
We can't. Simplify it, you mean?
yeah.
No, it can't be simplified. You can't do anything with the square root of 2. You can't multiply them together because that 5's not under a square root. Okay? It's simplified right there. It's done. Question is, do we simplify it? Yes, we do. But you can't do anything else with it. It's already simplified. That's all we can do. Okay? What do you think? That's pretty easy, isn't it? It's hardly any math at all. All you got to do is just stick a square root of 2 next to the leg and you're done. That's it. Well, kind of. Let's do this. I said kind of. I mean, that's the rule. It's just a matter of applying the rule now to different things. What if I said that this was the square root of 3, and I wanted to find the 2 missing sides? Well, first of all, the bottom's the easiest. What's that? Square root of 3. Now, how do I find the hypotenuse if I know the leg? Do you remember the relationship? Let's write it down again. The hypotenuse is equal to what? The square root of 2 times what? L, or one of the legs. This is kind of a little more general right here, okay? Oopsie daisy, what did I just do?
You moved the viewing.
I sure did. How did I do that?
I think you clicked the green.
I think yeah, how did I? Oh, wow, I didn't even know you could do that. Is that where it was?
Yeah.
Good enough.
Sorry, YouTube.
Yeah, for all my millions of fans on YouTube, it probably really bothered them. Okay. Sure. Alright, so here we go. There's our little relationship. What do we do to find the hypotenuse? We take the leg and we do what to it? Multiply by the square root of 2. So if I take the square root of 3, multiply it by the square root of 2, what's that going to give me? Very good. That's the square root of 6. Because they're both square roots, so I can put them both underneath one square root. Everybody see that? Remember the rules for this? And then that's just the square root of 6. If that was just a plain old 3, it would just have to stay 3 square root of 2. But it's a square root of 3. I can multiply the two things together, and it goes right there. Simple. Would you agree?
Yes.
Sure. Let's change it around again. Just trying to think of different scenarios. Or scenarios.
What if they give you the hypotenuse?
Ah, that's good. What if they did? What if they gave you the hypotenuse?
If it's so hard that you're going to think me.
Oh, we are thinking. We are thinking you. Yeah, what if I said the hypotenuse was 7 and I wanted to find one of these legs? Well, look, you could come back to your little formula right here. Okay, let's... Well, you really can't because you don't know one of these other sides. You only know one side right here.
Would you divide that by the square root?
Okay. Yes, you would. Let's do this. Let's plug it back into our formula just to see why we would do that. Okay. The hypotenuse equals the square root of 2 times one of the legs. We'll call the leg A. Is that all right? And so, of course, that one and that wouldn't be the same exact thing because it's 45, 45, 90. So, look, let's put the number in for this. Hypotenuse is 7 equals the square root of 2 times what? A. Now, how do we solve for A? Divide by the square root of 2, and you're exactly right. You would just divide it by the square root of 2. So, look, if you know the leg, how do you get the hypotenuse? You multiply it by the square root of 2. If you know the hypotenuse, how do you get the leg? You divide it by the square root of 2. Do you see it? Pretty simple. But, exactly right. We don't leave it like that, do we? Is that how we want to leave it? No. Why is that not simplified?
Because there's the square. There's a radical. Because you can't have a radical.
That's right. You can't have a radical on the bottom. Okay, they call it, oh my gosh, just slipped my mind. No, they just call it rationalizing the denominator. How's that for a fancy term? You ever hear that before? Rationalizing the denominator. All right? Which means get rid of the square root in the bottom, okay, in everyday words. So let's put this over here. So what do we do?
What we did yesterday.
Do what we did. Yep. Square root of 2 over square root of 2. Why can we do that? Because what is the square root of 2 over the square root of 2? It's just a 1, isn't it? So I'm allowed to do that. But what happens? I get 7 square root of 2 over what? Square root of 2 times square root of 2, which is square root of 4, which is 2. Alright? That's what A is, right there. Okay? That's the simplified version. So that's. Let's just check to see if it works. Remember what we said? If I take the leg and I multiply it by square root of 2, I should get this. And you're like, well, wait a minute. If I multiply this by square root of 2, there's no way that's going to equal this. Because what's all that crazy stuff? Well, let's see if it works. Watch. 7 square root of 2 over 2. What did I say to multiply it by? The square root of 2, right? And it should equal 7. Let's see if it does. Yep. What's square root of 2 times square root of 2? It's 2. 7 times what? 2. Over 2. Cancel out. Yep, sure enough, it does equal 7. So it works, doesn't it? Okay, isn't that cool? Yep.
What if you, like, in the end, you can't, like, with the 7 times the square root of 2 over 2, what if that couldn't be simplified? Would you want us to do a decimal times the square root of 2?
No, just keep it like that. Keep it exactly the way it is. Okay. See, it's circled because that's how I want you to write your answer. This is exactly how I want you to write your answer. I have no problem writing answers in improper fractions. Okay, when you're a kid in elementary school and early middle school, your teachers probably always harp on you, don't they, to change an improper to a mixed number. In algebra, though, it's perfectly fine to keep it as a improper fraction. I have no problem with you keeping it as an improper. Okay. Yeah, I mean, mixed numbers are good. I mean, like, if I said, hey, measure that wall, and you said, well, it's 384 over 6, or, 192 or something like that, that would be dumb. You'd say, no, it's 2 point whatever feet, or whatever the thing was, okay? Does that make sense? So, in real life, sure, you would change things to a mixed number or a decimal, but when we're dealing with algebra, there's a lot of times where it's way, way, way better keeping it improper than it is a mixed number, okay? So let's keep things as improper, when it's a good time to do that. All right, let's keep going. So that's one triangle. I don't think there's anything. Oh, I could have done this. This is actually pretty easy. I could have. Sometimes they'll do this. They'll say, all right, that hypotenuse is like 7 square root of 2. What if that was 7 square root of 2? What would this leg and this leg be?
7.
Just be 7, wouldn't it? That's pretty easy, isn't it? Because what do? We just divide it by the square root of 2. So just in your head, you could just write down 7. And what would this be? That would be 7. Okay? Providing that was 45, 45, 90. Forgot that. Okay? Well, let's think of something else kind of maybe crazy that they could give you here. Maybe they'll give you, like, I don't know.
No numbers or variables?
I don't know, like 3 square root of 5. I don't know. I'm just making something up. And they ask for this side right here. Well, what do? You take 3 square root of 5. Let's do it down here. How do you find this? What do you do to this number to get this leg? Divide it by the square root of 2. Right?
Yeah.
Now, we don't leave it like that, though, do we?
Nah.
So what do? Multiply it by the square root of 2 over the square root of 2. We get, what? 3 square root of 10 over 2, and that's your answer. So that side right there would be 3 squared of 10 over 2. I know it looks like a stupid answer, a stupid way to write the answer, but that's exact. Okay, that's an exact answer. It's not an approximation, and it's simplified. And of course, this would be the same thing. I don't know if they would give you that or not, but I'm just thinking off the top of my head what they could possibly give you. All right, let's move on. Are we ready to move on from a 45, 45, 90? Yeah. So again, what was the relationship? The hypotenuse was what? The square root of 2 times what?
L.
One of the legs. Now, I didn't specify which leg because what's true about the 2 legs? They're both equal to each other. All right, that was fun. Let's do another one.
Can we have no fun? That's fun.
What?
Too late.
You crazy?
Yeah.
We're all about fun in this class.
JW.
All about fun. All right. What about this one?
I'm telling you, you gotta put elevator music.
What if this was 30 degrees right here? What would this angle up here be?
60.
It'd be 60. Okay, so this is not a 45, 45, 90. Take a wild guess what we call this one.
I find it.
A 30, 60, 90.
How about 30, 60, 90?
Yeah.
Okay. All right. Now look at this. Something a little bit different about this. first of all, the angles aren't the same. Okay, now they both do have a right angle, don't they? But also, the two sides are not equal to each other. So I don't just have, I'm not going to just call this L and call this L. Do you agree? There is a relationship, though, between these three sides. That's what I want to show you. There's actually two different relationships between them. Which one is the very longest side out of the whole entire triangle? The hypotenuse is always the longest side. Okay, we'll just call it HYP. Why? Because it's opposite what? The 90-degree angle. And the 90-degree angle is the biggest angle, right? Which one is the shortest side out of the whole thing? Across from the 30. That's right. This one goes up and down right here. And I'm going to call this the short side. Okay? This one right here, I should say the short leg. Let's call it the short leg. Is that all right? Let's listen and not worry so much about all the funny remarks, okay? Watch. This right here is the short side. We're going to call this. Now, this isn't the longest side of the whole triangle, but as far as the two legs are concerned, this is the short leg, and I would call this one the long leg, okay? Or you could say the longer leg, right? You wouldn't say the longest leg. Did you know that?
Yes.
In English, if you have two things or you're comparing them, you don't say it's the longest, you say it's the longer of the two. Oh, did you really? Okay, good. Well, there you go. So let's do this. Let's figure out some kind of relationship. When do we get out of here? 12 after? I wonder if I want to do this or not. There's a little bit of a proof. I'll try to do this real quick. Do you mind?
Well, honestly.
You don't mind, do you?
Yes.
You probably want to see this. You probably don't want to accept this just on just me saying it, do you?
Yes.
Yeah, we do.
Come on. You
Majority vote.
guys are breaking my heart.
We win. Even though no one did except I came in.
Need to have an appreciation for this. Okay, watch this. Here's a triangle. Come on. Actually, you know what? I'm going to get rid of this. Get rid of this. And I'm going to do this. Okay, this is an equilateral triangle. Alright, so watch. I'm going to take this. It's supposed to be equilateral. I don't know how accurate it is. It's probably accurate. I think I made it some time ago. Probably is. So it's an equilateral, which means, what's this angle right here? If this is an equilateral triangle, it's 60, because if it's equilateral, it's also equiangular, correct? So that's 60. And this whole big angle up here is 60. I dropped a perpendicular down like this. So these two triangles are now congruent to each other. So that means if this is perpendicular, it also bisects this angle up here. So what's this little angle right here? That's 30, and this angle is 30. Guess what I have? I have a 30, 60, 90 triangle. Now watch. This angle, or this side, and this whole side is equal to each other. Would you agree? Just for fun, I'm going to call this 2x, just to make this work out real nice and easy. If I call this 2x, what's this whole thing? 2x. Now watch this. This whole entire bottom is also going to be 2x, but what would it be from here to here? It'd be x, because it's a bisector, right? It hits here at its midpoint, so this would be x. So, let's see if I can do this. I want to see a relationship between the longer side, and let's do the hypotenuse first. Look at the hypotenuse. The hypotenuse is 2x, and the short side, this is the short side, that's 1x. Tell me something, what's the relationship between the hypotenuse and the shorter side?
X is half.
Okay. Well, yeah, or the longer side. What's the relationship between the hypotenuse and the short side? The hypotenuse is twice as big, isn't it? So here's a little statement for you. Let's do this in another color. Watch. The hypotenuse is equal to what? 2 times the what? Not just the leg, but what? The short leg. The short one. Right? This is the short one. This is the long one. Okay? This is twice as big as this. Everybody get it? This is 2x. This is 1x. This has got to be twice as big as this. So that's one relationship that we know. We know two relationships on 30, 60, 90, though, as opposed to one on the 45, 45, 90. Let's do this one. Let's find the long leg. We'll call that L for long. Okay? What can we do? We can do a little bit of whatchamacallit. Tell you what, let's just call it something else. Let's call it A. Is that all right? We can do a little Pythagorean theorem, can't we? So look at this. A squared plus what? X squared equals 2x squared. Agreed? Because of the Pythagorean theorem. What I want to do is I want to get a by itself. So watch. A squared plus x squared equals, what's that going to be? 4x squared. So a squared. Subtract 1x squared from both sides. What's that going to be? 3x squared. Now watch where I'm going with this. Take the square root of both sides. So a equals square root of this. What? The square root of 3 times x. So check this out. A, this hypotenuse right here, or not, I'm sorry, it's not the hypotenuse. This longer leg right here, A, is what? What's the relationship? It's the square root of 3 times x, which is what? It's x, the shorter side, the shorter side. So let's do this. Let's write it like this. The long leg then is equal to not twice the short leg, but what? The square root of 3 times the short leg. And that was just a little proof to show you why that was true. I didn't do that for the first class because we ran a little short on time, but I did it for you guys. Don't you feel special now? Okay, all right. But there it is. That's pretty interesting. Now here's how I remember it. 2 is the same thing as the square root of 4, isn't it? So look, the hypotenuse, listen please, the hypotenuse is twice as big as the short side or the short leg. The long side is just a little bit shorter than the hypotenuse. Well, what's just a little bit smaller than the square root of 4? What would you think? The square root of 3 is, right? Square root of 3 is just a little bit smaller than the square root of 4, so that's how I remember it anyway. Okay, that the long leg is just a little bit smaller than the hypotenuse. The hypotenuse is twice as big as the short side. The long leg is just a little bit smaller, the square root of 3 times the short side. And there's our two relationships right there. What do you think? Is that all right? All right, let's do an example. Do you mind? Oops, I don't want that one. It's a rhetorical question. I don't care if you mind, tell you the truth. To be honest with you, since you talked about honesty. Just trying to be polite is all I'm trying to do. All right. Boom, boom. Let's get. Wow, did a lot of stuff today, didn't we? Boom, 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 boom. Okay. No. Come on, what's with you guys? All these negative comments. Guys are honors geometry. You should be psyched about learning this stuff.
Rachel's the only one who's like smiling.
Here we go. You all should be smiling.
I always smile. I can't help it. It's just something I do.
My dog got this one. She laughs.
Here we go. Ready?
I know it's not true.
We listening? Here's an example. Let's take a look and use some of the stuff that we learned to figure out what x and y is equal to. We know the long side, don't we? All right. Well, do we have a relationship that deals with the long side? Let's write it down. What's the long side equal to? It's equal to what? The square root of 3 times the short side. Okay? Got it in your notes, right? All you had to do is just look down at your notes and you could have just recited it by rote if you took notes.
Allie.
No. If you didn't see that on YouTube, that was glaring eyes at Matt because he wasn't taking notes. Okay, here we go. So the long side is the square root of 3 times the short side. What do we know here? We know the long side, don't we? So we know that's 15 equals the square root of 3 times the short side, which is what? X, right? Divided by the square root of 3. Are you following me? And so x is equal to 15 over the square root of 3. But we don't leave it like that. How do we write it? We write it like this. So let's see what that is. It's what? 15 square root of 3 over 3. Do we leave it like that?
Possibly.
Come on. No. Because
3.
3... Yes, very good. It's 5 square root of 3. There it is. Okay, so that's what x is. Now look, once you find the short side, you're home free, as they say. Because once you get the short side, it's easy to find the other two. It's really easy to find the hypotenuse. What do we do to this to find the hypotenuse? What is it? By 2, right, multiplied by 2. Just double it, okay? So if I take this and I multiply it by 2, what do I get? 10 Square root of 3. Not 6. Where do you get 6
I
from?
multiply 3 by 2.
We just had a big talk about it. You can't multiply 3 times that, okay? So there you go. Look, here, this is a common mistake that students make all the time. If I said, okay, here's 2 times 5, let's say, and I said, let's take this and multiply it by 3, all right? Do you multiply the 2 by 3 and the 5 by 3?
Don't you multiply the whole thing?
Yeah, the whole thing, or you can multiply just either one of these. It doesn't make any difference. Watch. Look, you could just multiply the whole thing and say 3 times 10 is what? 30. Or you could do what? 3 times 2 is 6, and then times 5 is 30. Or you could go 3 times what? 5, which is 15, times 2, which is 30. You follow me? For some reason, when you just said that, you're not the only one that said that. A lot of students, for some reason, think they have to take the 3 and multiply it by both of them. I almost hate even writing that down because people will remember what I tell you not to remember. Right? But you're not multiplying 3 by both of the things in here. Right? You either multiply it by one or the other, or you multiply these together and multiply it by 3. All right, that's enough of that. All right, does that make sense? That's how we can find those 3 sides. So that was 30, 60, 90, and we also did 45, 45, 90. And look at the YouTube video if you get a little confused on what's what. I would definitely write this down somewhere. See, I put them in boxes and everything. You see all that? That's very important. We did the same thing with the 30 right here. That right there. That's very important. Write those 3 things down because they really come into play a lot. We use it even a lot later when we start doing trig stuff, when you do some higher algebra 2 stuff. We're going to come back to this stuff and we're going to say, hey, remember in geometry when we learned that the hypotenuse was the square root of 2 times one of the legs. And you're like, yeah, I remember that. Then you come back to this and you'll be good to go. All right, let me give you some problems to work on. I hate to send you home with nothing to do.
I would hate to send us home with.
Remember, this is a good thing. Shh, hush. Listen to me. I'm not finished. This is a good thing. All right, because the only way you're going to learn this stuff is if you practice it. If you just sit here and listen to me and just watch me, even go to the YouTube and watch it once or twice, you're not really going to learn it. You'll only learn it by doing. Okay, so you should be thanking me, not groaning and complaining about doing this so it works. So here it is, and then you can go. So it's page 556, 557, and we're doing 8 to 25. It's really not that much. Okay? There it is, 8 to 25.
I get Miss Warrington's stuff.